Hello, ninth grade algebra students. It is Miss Bowman here with another math video. We are here for week 2, lesson 2, and we are talking about combining like terms. It has not been a long time coming. I was going to say it's been a long time coming to get here. That is not the case. Let's jump right in. So combining like terms. Before we can talk about combining like terms, we have to describe what is a term. So what is a term? If I write a math sentence out right here, so I'm going to write 7x plus 3 minus 5x plus 8 plus 4x minus 1. Nice. I want to be able to write that more simply. So to put it simply, combining like terms is simplifying. I'm trying to simplify an expression. An expression, remember, is a string of numbers that don't have an equal sign. There's no equal sign on the outside of that. Otherwise, we'd be looking at an equation. So I want to write this as simply as possible. 7x plus 3 minus 5x plus 8 plus 4x minus 1. But before I can do that, we have to talk about what variable terms are and what constant terms are. First, the definition of a term. A term, can I write term? A term is a word in a math sentence, So for example, 7x would be like a word in a math sentence. It is a term. 3 is also a term. So is 5x, so is 8, so is 4x, so is this minus 1 there. Those are all terms in the math sentence, but they are not the same kind of terms. So when we're combining them, we only want to combine terms that are the same. So there are things called variable terms. An example of a variable term would be 7x. It has a variable on it. Notice when I'm reading it, when I'm saying it out loud, I'm not just saying 7 and x, it is 7x. They are one, they are together. Another variable term would be the minus 5x or 4x if I'm looking at the example that I have above. These are all of the terms, all of the words in my math sentence that are separated by plus or minuses that have variables. The constant terms are the terms that do not have variables. So in this case, we have 3, 8, -1. These are always going to be just numbers. So we're looking for the parts of our expression that don't have any variables at all. There's one more word we have to know. We're talking about that number in front of the variable term. That is called a coefficient. It is the number next to the variable. So in these cases, our numbers next to the variable, our coefficients, are 7, -5, and 4. And I'm going to be saying the word coefficient a lot today. Remember, the coefficient is the number next to the variable. So let's talk about what we're actually trying to do. You can simplify an algebraic expression by combining like terms. This means to combine variable terms and constant terms. And by combine, I mean we're going to count how many we have. Count how many there are. Our goal when we simplify anything is to write as simply as possible. So I'm trying to write as simply as possible. I'm trying to write these math sentences as simply as possible, meaning I want to use the least amount of words or the least amount of terms that I can. And I'm going to do that by combining or counting up the variable terms that I see and the constant terms that I see. So let's do that example from what I put at the top. We already noted that 7x, this -5x, and this 4x are all variable terms. We're going to focus on the coefficients in front of those variable terms. 7, -5, and 4. And notice how I'm taking like this negative sign with the 5. I'm keeping track of whether it's something that's being added or something that's being subtracted. What is 7 minus 5 plus 4? 7 minus 5 is 2, plus 4 is 6. I am taking 7 x's, I'm subtracting 5 of those x's, and I'm adding back 4 more. I'm combining these terms. I'm counting up how many x's I'm going to have at the end of all of this. So 7 minus 5 plus 4, I'm going to be left with 6 x's. So if I were to combine, if I were to mash all 3 of those terms together, there would only be 6 x's. So instead of writing it out all long, I'm just going to write 6x. So part of my answer is 6x. The other kind of term that we have to look at is constant terms. I'm going to highlight them in this pink. We have 3, 8, and -1. I'm going to almost make this into its own math problem over here. I have a positive 3, it's a positive 8, so plus 8, and then -1, -1. I have 3 plus 8 minus 1. 3 plus 8 is 11, minus 1 is 10. Oh, where did we go? -1 is 10. There we go. And this is a positive 10. If I were to take now the 6x and the 10, I can write the expression that we had above simplified. 7x plus 3 minus 5x plus 8 plus 4x minus 1 can be most simply written as 6x plus 10. I combined my variable terms, so the terms that had the same variable attached to it, which in this case was the x, and my constant terms, which were the words or the terms in my sentence that didn't have a variable. In that case, it was just those numbers that we saw. A couple more examples. I have 3x plus 6x. When I am combining variable terms, so terms that have a variable, like these both have an x, I am counting up how many of them there are based off of that coefficient. If you have 3 x's in one hand and 6 in the other, and you smash them together, how many x's do you have? Or if you have 3 apples at home and you just bought 6 more, how many apples are you going to have in total? That's a classic math teacher problem. But in total, I'm going to have 9 apples, or 9 x's in this case. X is just the variable. It's just a letter there that's standing in for something else. Our next problem, we have 9a minus 10a. I want to know how many a's there are. How can I write this most simply? Remember, we're looking at the coefficients. I know this is a variable term. They both have a's. So what I'm really asking you is, what is 9 minus 10? And 9 minus 10 is -1. And I'm going to write out my answer as -1, because that's 9 minus 10. And I'm going to tack the a on at the end, because we are looking at a variable expression. So the variable comes with into the answer. So if I had 9 a's in one hand and -10 a's in the other, I'm going to be left with -1 a's when I smash my hands together, when I clap, 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 clap. Okay, we have another problem, 7m minus 5m minus 6. I'm going to highlight the things that are the same. I'm going to highlight all of the variable terms. I have a 7m and I have a minus 5m. I'm going to highlight both of those in blue, and I will highlight the constant term, the number, in that kind of light pink. I'm doing this so I can see which parts am I combining. I'm combining these two blue parts right here. So 7m minus 5m. Remember, looking at the coefficients, 7 minus 5 is 2, so I'm left with 2m. I have this -6 kind of chilling at the end. There are no other constant terms for me to combine with it, so it just gets to scoot down here next to the 2m. So 7m minus 5m minus 6, most simply put, is 2m minus 6. All right, over here we have 26a plus 2b minus 4a plus 10b. I'm going to highlight the things that have the same variable, because here we're working with a's and b's. We have two different types of variable terms. I have 26a and I have -4a, and then I also have 2b and 10b. I'm going to draw, I like to draw little arrows to my two little clouds there to keep track of like what kind of operation is happening. So 26 A's in one hand and negative 4 A's in the other. So I'm taking 4A away from 26A, or rather I'm doing 26 minus 4, which is 22. So I have 22A. How many B's am I going to have? I have 2 here and I have 10 here. If I smash my hands together, clap, 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 clap. 2 plus 10, adding my coefficients, is 12. So I have 22A plus 12B. I cannot do anything more. These do not have the same variables. Up until now, we've only been looking at things that do have the same variables. These do not. I cannot clap together A and B. They don't have anything in common. This is as far as I go, is 22A plus 12B. So we talked about, now we had, two different variables. But what about if we have variables, a variable term that has exponents? So I'm talking about terms like x squared, or 5t to the fifth, or negative 6m to the third. What if I have terms with exponents? Well, if we have two of the same terms, so two of the same kind of exponents, so if I have 5x squared minus 3x squared, those are like terms. They have the same exact variable with the same exact exponent. And when I combine these like terms, the exponents are not going to change. They are going to stay the same. My example right here is 5x squared plus 7x squared. Notice that like the thing I say after the number is the same. X squared, x squared. So 5x squared plus 7x squared, focusing on my coefficients, is going to give me 12x squared. The variable and the exponent did not change. The thing that did change was the coefficient. The number of x squareds that I had increased because I did 5 plus 7, clapped them together, got 12. I have negative 15n to the fifth, 4n to the fifth. I'm going to have an answer that is in terms of n to the fifth. And I want to know negative 15 plus 4, which is going to be negative 11. When I combine those, that is what I get. I got a little bit of a bigger string right here that we're going to have to do some highlighting on. I first see I have an 8k squared. I'm going to look through the rest of the problem and see if there are any other terms that have a k squared. So I have 8k squared minus k minus 5k plus 7 minus 2k squared. Nice. Let's highlight everything that we can. I have a negative k. I also have a minus 5k. So I have two terms that have a k. And then I have a plus 7. Plus 7. I highlighted all of the different terms that I can combine. I have 8k squared. The same, another term that had a k squared was negative 2k squared. So I'm doing 8 minus 2 to find out the coefficient. 8 minus 2, which is 6k squared. There are 6k squareds here. I have a negative k and a negative 5k. There is a number in front of that k. It is there, but it isn't there, but it is there. That number is a 1. If it is not explicitly written there, meaning if it isn't just like written as negative 1k, in front of every variable, if there isn't a different coefficient, there is a 1. It is a hidden 1. That is just how math is. But here I have negative 1k minus 5k. Whatever these are when they're combined, it's going to have a k. Negative 1 minus 5 is negative 6. So I'm going to have a minus 6k. And then the very last term I have is this plus 7, which just chills at the end. There's no other numbers, no other constants for it to combine with. This is as simplified as that gets. I have one last one. I wanted to put this example here because it has something kind of strange. It has this whole concept of AB. So it's two variables next to that 7. Let me read this out loud though. 6a squared plus 7ab minus 10ab plus 12. There are two terms here that have the same exact variables next to the coefficients. And that is 7ab and negative 10ab. They both have a and they both have b. These other guys, though, a squared and b squared, there are no other terms that have an a squared or have a b squared. So the only thing I need to combine is this guy in the middle. So I'm looking at my coefficients. Whatever comes out, it's going to come out with an AB because that is the variable for those terms. 7 minus 10 is negative 3. So I'm going to have negative 3AB. My friends up above, the a squared and the b squared, come on down just as they are because there's nothing for them to combine with. There are no other terms that have a squared. There are no other terms that have b squared. So they're all lonely on their own. This has been Combining Like Terms with Bowman. Check out our homework, email me with questions, hit me up. I am more than willing to help you whenever you need it. All right, have a great day. Bye.